A 14.5 kilogram mass fastened to the end of a steel wire of unstretched length, so this is the original length, 1 meter, is whirled in a vertical circle with an angular velocity of 2 revolutions per second. So we have a vertical circle here in which a wire is revolving like this. So some mass is tied to this wire, mass of 14.5 kilogram. Okay. The angular velocity is given. The cross-sectional area of the wire is given. Calculate the elongation of the wire when the mass is at its lowest point of its path. So the elongation, that means we have to find out the delta L. So delta L has to be found out when it is at the lowermost position. So at its lowermost position, the force experienced are a downward force, downward gravitational force, that is mg. Now centripetal force has to be provided to this wire in order for it to rotate. So centripetal force here is Fc. The wire is also tensed. So the centripetal force, that is the force towards the center, is T, and that away from the center is mg. So the centripetal force is T minus mg. Therefore tension in the wire is centripetal force plus mg. Centripetal force is m omega square r plus mg. So this is m omega square r plus g. So this gives us 14.5. Omega is 2 revolutions per second. So we can't take a revolution to be standard unit. So we have to multiply 2 pi to it square. The radius is given to be, that is, the length of the wire is given to be 1 meter. Let's take G to be 9.8. So this gives us a tension of 2431.8 newtons. So this is the tension in the wire. Okay. So we need this tension to calculate the elongation. So here we are going to use Hooke's law that tells us stress is equal to Young's modulus times strain. Therefore, force in the wire per unit area is Young's modulus times delta L by original length. So change in length is going to be TL by 8 times Y. So let's put these values. So T is 2431.8. The length of the wire is 1 meter. Cross-sectional area is given to be 0.065 centimeter square. So we have to put a 10 raised to minus 4 to convert it into meter square. So 0.065 into 10 raised to minus 4. Since this is a steel wire, the Young's modulus of steel is 2 into 10 raised to 11. You got to remember this. Okay, calculating this, we get, so this is 1.87 into 10 to the power minus 3 meter. So this is the elongation we get. So this is 1.87 millimeter. So at the lowest point, the wire is elongated by this much. Okay.